Hello, today we're going to make a mask detection program using the YOLO v3 algorithm. For this, first we need a dataset. The getting the dataset is easy. We can use Google for it. You just have to search people with mask. You'll get a ton of images. To download all these images easily, we can use an extension called download all images. It'll show up on your browser like this. You just have to click this button and all these images will be downloaded in a zipped format. Then we have to annotate these images. For this we will use a simple program called label.img. It is made to annotate these images and save it in the format so that it can be readable by the YOLO v3 algorithm. The format is a simple format in which it contains the first four are the coordinates, first four are the numbers which detail how where the box is. It contains the center coordinates x and y, and then the width and the height of the image. After this you have to zip the image and save it in a folder in your drive like so. And after that we can go to the Google Colab notebook to implement training. First we mount the drive, then we clone the GitHub repository with the YOLO v3 implementation. We change our folder to the darknet folder and we make changes to enable OpenCV, GPU and CUDNN so that we can we can make training faster. First, we have to remember to change your runtime from CPU to GPU for this to take effect. Now we'll copy the YOLO v3 config file and make a new file called YOLO v3 training. We'll change the number of batches to 64. We change the subdivision to 16, and we'll change the max batches to 4000, which is the number of times we want to train. The number of batch batches is mostly determined using the formula 2000 into classes. We change the number of classes to 2. We change the number of filters to 21. Now we'll make a text file called object.names in the data folder with the name of our labels, which is not wearing mask and wearing mask. We'll make another file object.data which will contain the number of classes, the location of the train data, the location of the validation data, the test data, and the location where we have to save the weights in case the training is interrupted. The weights are only saved every 1000 iterations. Now we'll copy the YOLO v3 training CFG on our drive with the name testing CFG. We'll copy the object.names text file which contains the name of the objects into our drive with the name classes.txt. We'll make a new directory called object in the within the folder data, and we'll unzip all the images, annotated images in this text file in this directory. Using the glob function, now we'll make a new text file .train.txt and append all the name of the images in this text file. Now we'll download the weights from this link. As we are using transfer learning, downloading the weights and will help us fasten our process of training the dataset. Using a simple command like this darknet detector train, we'll input the data object.data file, the training CFG, and the pre-trained weights, and then start training. If your training is interrupted in between, you can just use the below line to continue training. After this is completed, your training weights will be saved in your backup folder as shown as YOLO v3 training after 1000 iterations, after 2000, after 3000, and after 4000, and these are the final training weights. Now you can use a simple Python script to utilize this. We use OpenCV and NumPy. We load the CFG and the training weights into a network. We make a list with the names of the classes. We load the image, and then we pass the image through the network to see what detections it has made. You can set the confidence here as the results may vary. For me, the confidence 0.4 seemed to work pretty well. Now using OpenCV, we can put bounding boxes and text on the images that on the labels that it is identified in the image, like shown. See, this is the image that we input in our network, and this is the output that we got. It made all the bounding boxes around people not wearing and wearing mask, and it has made a prediction quite well. As you can see, the confidence is quite high. We can use the same script with a few changes to also work on video input. Since YOLO V3 is a pretty fast algorithm, it will give an output of around 15 to 20 FPS depending on your GPU. Thank you.